Hi all. Thanks for attending my session, and yeah, this is about the elephant in this room these days, AI, and in particular agentic AI patterns. So how you can put together different agents to work to work together. Okay, so yeah, a few words about me. My name is Mario Fusco. I'm from Italy. I work for IBM, and I'm one of the main committer of blockchain for J. And today I'm here to speak about the work that I did on agentic AI patterns in the latest few months. Okay, so before this, let me clarify something. So why I'm doing this in Java, right? It is because every all the world do this in Python. AI seems to be a Python kingdom, and everybody's surprised when I say that I work with AI, but in Java. But the fact is that I'm not a data scientist. What I don't create models. I'm not a mathematician. So what I do is basically taking existing model from the internet, from Hacking Face or some other repository, or from or Llama. And then what I do, I try to make this thing to work into existing enterprise grade system application. And guess what? All of these systems are basically written in Java. You don't want to reinvent the wheel in Python because you need all the enterprise feature that you are normally have. I don't know, in a legacy bank application. You want to add some AI to it, and of course, the legacy bank application is written in Java, and you want to keep doing this stuff in Java as well. So this is why I believe that Java is still relevant also in this field, and why I'm doing this integration in Java. So in essence, okay, I'm happy that it works on your Jupyter notebook, but you know what? We are not going to ship it. That's the thing, right? What I will tell you today, it's a 4 steps journey that I did while implementing this agentic AI framework, on which I'm still working. So this is still a work in progress, of course. I will tell you how we started from a single AI service, from a single agent, how we initially put more agents together in predefined workflow, and how can you do this with agentic like 4J, and then how we implemented another pattern to give some autonomy to this agentic system, and let it decide how to invoke the different agents autonomously. And finally, we figured out that there is no one size fit all algorithm that is good for each and every problem. So what I did is generalize what I developed so far, and allow to plug your own strategy to decide the sequence of agents to be called in your own specific agentic system. Okay, so I'm speaking. I will describe these 4 steps in sequence, but what happened in reality is more similar to this, right? So it's something really new, I guess, for many of us, for almost everybody, and especially for myself. So I had a lot. I still have lots of doubt. I still a lot of rethinking, a lot of reworking. So I keep change my mind about stuff that I thought it was consolidated, but in reality it was not. So this is to say that this is still let's say, experimental area, and it's still growing in in this way, exactly this way. Okay, it's in this not very linear way. Okay, I want to pass the message that this development of these 4 stages that I'm presenting to you today, it's not as linear as it seems. Okay, so as I said, the first step is that everything started with a single AI service. So with a single LLM, we have an application with an LLM, but of course, even for a single agent, this is not enough. First of all, you need a well-crafted prompt, and if you have done this on your own, you probably know how much time you can spend trying to create a prompt with which the LLM is happy. So this is another very time-consuming task. Of course, you need chat memory because the LLM are basically stateless, but you want the agent to remember the context, to remember the interaction. So you provide the LLM with an external memory, and then very likely you want to have function calling to call external system. For instance, I don't know, to do a web search, to do some math in a more reliable way, because still LLM alone are not really good at math. In essence, you want to call external functions, okay? And then, of course, you want to connect your LLM with some sort of data source, both to make the memory persistent, but also to implement the RAG pattern, to help the LLM to provide more context to the LLM with a meaningful context that is taken from typically from a vectorial database using the RAG pattern. And finally, you want to have more control on the input and output of the guardrails. You want an input guardrails to avoid for security reason, to avoid prompt injection, for instance, or any malicious usage that anybody can do of your system. And you also want to have an output guardrails to control that the outcome of the LLM is appropriate, is not I don't know, replying to the user with any inappropriate way, okay, or touching any sensible topic. Okay, so this is a single AI service. This was really my starting point when I start developing and thinking about how to put more of these things together. Okay, so what I described so far is what is called a single AI service in LangChain4j, and then we want to create an agentic system. So to me, the difference between a single AI service and an agent is that is simply that an agent is an AI service that is not supposed to work in isolation, but is supposed to collaborate with other agents to achieve more complex tasks and to pursue a common goal. Okay, so that's why we want to have more agents collaborating together. In some cases, one question could be, okay, when I need more agent or when I need a more beefed LLM, can't I do this can't I do everything with a single agent? And in many cases, the answer is no. First, for cost reason, because if you use a super huge LLM, it could be expensive. while you may want to have some LLM that are tailored for a very specific task. So you can put smaller LLM together that are good enough because they have been trained for a specific task. And second, it's the usual divide et impera pattern that we use since decade in information technology, and it also applies very well to this domain. You don't want to give to the LLM a very complex and huge task. You want to split this task in subtask and have an agent specialized to fulfill any of these subtasks. Okay, so I started working on this agentic modeling LangChain 4J this summer. We dropped a first release of this agentic module in August with LangChain 4J 1.3.0. At the moment, we are moving fast, sometimes breaking things, meaning that we are still changing the public API of this thing. But as I said, we are moving fast. We are already at version 1.10, 1.0, meaning that we basically are doing one release a month. So we are really moving this thing forward as fast as possible. So the first way in which I experimented combining more agent was through the workflow pattern. Okay, they are workflow, but in my opinion, the workflow word is a bit misleading in this circumstance. I mean, what I was looking for were patterns through which more agent can collaborate. Okay, and so normally what happens is you have a big task, you divide this in subtasks, and then you put this subtask together, and you end up with a workflow. But it's not a workflow, let's say, in a JBPM terms of the word. It's just a way to combine more agents together. Okay, and in literature, these things, of course, are called agentic workflow. I believe the first time that this definition appeared was November 2024 with a paper from Anthropic describing these four basic patterns. So the basic pattern are the sequence when you do what is called the prompt chaining, meaning that you use the output of an agent simply as the input for the subsequent agent, and then you have the loop reflection when you do a loop calling the same LLM again and again in order to refine what it did. And then, of course, in some cases, you may want to call different agents in parallel, maybe because they are supposed to do independent tasks, and then you want to aggregate the result. And finally, you can have some conditional routing, meaning that you call one agent or another based on some condition. Okay, so these are the four very basic patterns. But before we go into these patterns in more detail, what I wanted again was to create a service by wrapping more agent. So this is the very first example, right? In this example, I started with 3 independent agents. Okay, the first agent takes a topic and generates a story about the topic. The second agent is supposed to edit a story for a given audience, and the third agent is supposed to still edit a story, but this time for a specific style. Okay, so I have these 3 independent agents at this point. But what I would like to do is to put these 3 things together, okay, and make them appear to the end user as one single service, as one single agent. So I want to provide this thing with the required topic, audience, and style, and I want this to generate the story. So this is the uh, public API that I want to give to my service. Okay, so in reality, what I want is this thing is having an interface, a public API that generates a story and takes these three things: the topic, the audience, and the styles as input, and return the story. So I want something with this API that internally uses the three agents that I described in the former slide. Okay, so what I do is what I do in LangChain4j is that I start with the definition of these three agents, where I give to them the signature, the interface of the service that they implement. So again, I have this creative writer, the audience editor, and style editor, and I give a name to the output that they produce. Okay, and then I have this. I have many builders for all the different kind of pattern that I implemented. In this case, I'm creating a sequence of these three agents. So what happens here is that I'm creating again this service, taking in input the topic, the audience, and the style. And in these slides, you see how the logical flow of the variable inside the three agents. So the topic is passed to the first agent, it generates a story. The story together with the audience is passed to the second agent, which refines the story and output a different story. And the same happens with the style editor. And finally, you have the story that has been properly edited for a given audience and style. Okay, this is the logic flow of the value taken as input by the agent and generated in output. Okay, what happens in reality is that I have a shared state basically. Okay, so when you call the main service, the sequence, you call it with these three value, and these three value goes into the shared state, and then each and every agent is fed with the value present in the shared state, and also they write their output in the state as well. So this data structure in LangChain4j is called the agentic scope. The agentic scope not only has this shared state through which the different agents communicate, but it gives you a few more features like recording of the sequence of the invocation that have been performed. So it can create a wider context that can be used for to each and every agent. And about these context things, I have a demo later, so I will be back on it later. And okay, finally, this thing, this agentic scope data structure is also persistable with an SPI, so you can pose an agentic system, persist the agentic scope, and then resume it. Okay, so let me go through quickly about the other three workflow pattern that I anticipated before. So I have, in this case, a loop workflow. What I want to do is to have an agent that gives us a score to the generated story and say, and generates a score between 0 and 1 to say if the story fits well for a given style or not. So what I do here is that I create a loop between this scorer that gives a score and the style editor, and I keep doing this loop until the exit condition is met, that in this case is I want that the score is higher than 0.8. Okay. And what you can know, and you another possible exit condition of the loop is if you hit a threshold of the maximum number of iteration. The other thing that you can notice here is that I can have, in this case, an agent that is not backed by any interface, so you don't need to define an interface also for this loop agent. Mostly I do this when an agent our workflow is internal to a bigger agentic system, so it's not directly exposed to end user in this case, because still I have a sequence of two things now. I have a sequence of the created writer that which is the same that I had before and generate the story, and then the second agent in the sequence is not an agent alone. It's a workflow. So this is also a demonstration of how you can compose a different workflow. I have a sequence of an agent and a loop, and the loop is by itself another pattern. In this case, the loop pattern that I was mentioning. Okay. Well, okay, this is another very basic example, this time to demonstrate how the parallel workflow works. I want to create an evening plan for a nice evening based on a given mood. So I have two experts, one that decide the meal for the evening, let's say for a romantic evening, and a movie expert. So I have these two things that are of course independent, so they can run in parallel. And at the end, I have an aggregator function that puts the list of possible meals and list of possible movies together to create a list of plans for my evening. And this is an example of the fourth pattern. This is also quite typical. I have three experts here: an expert, a legal expert, a medical expert, and a technical expert. And my system can be queried about any of these three topics. So what I have is that I have one agent that simply decide which is the topic of the question, and then based on the categorization made by the first agent, I have this conditional routing that again, based on the fact if the category is medical, legal, or technical, decide to invoke the corresponding expert. Okay, so this is another quite typical workflow pattern. And as I said, I have this agentic scope that keeps the state and the shared state, of the agentic system, and also can eventually provide each and every agent with a context that is extracted from the iteration that the agentic scope had, which with any agent in the agentic system. So let me try to demonstrate this with an example that uses this last routing example that I just mentioned. So let me find the code. Okay, so this is the code that I have implementing this thing. All the code in my slide uses the programmatic API, but as you can see here, I have also a purely declarative API. This is especially convenient if you use the LangChain4j Quarkus extension, meaning that I'm not wiring this agent together programmatically, but I'm wiring them together via notation, as I will show you. So what I have here is I have this tree expert, the medical expert with a given user message and its own chat memory. And I have very similarly the legal expert and the technical expert. And then I have another agent that just does the classification of the user request. So it just decide which of these three category the request belong to. And then I have my conditional agent that takes the category, takes the category and decide to activate the medical expert in case the category is the medical one, and so on and so forth for the technical and the legal expert. Okay, and finally I have a sequence made by the category, the agent that does the categorization, and the agent that does the routing among the three experts. Okay, that's all I have. And then by using the Quarkus LangChain4j extension, I can also use CDI. So this is my, let's say, top level agent of my agentic system. So I can inject this thing into a REST endpoint with a WebSocket that is used to query this agentic system. Okay, so this is my application. Let me start it, and let's put this at. Let's try this. Okay, so this is running. Where is it? Okay. Okay, so this is my chatbot. My chatbot is asking me, okay, how can I help? How can I help? And I can say, for instance, I broke my leg. What should I do? So what should happen now is that the category agent decide that is a medical question, so it routes it to the medical expert, and this is the answer of the medical expert with a few suggestions on what I could do, right? Okay, so now I can continue my chat, and I could ask, for instance, should I sue my neighbor who caused this damage? So this time, as you can imagine, the request categorization is legal, so it goes to the legal expert. And the legal expert is providing me an answer, as you can see. What's the problem here? The problem here is that the response of the legal expert doesn't know anything of what it happens before. It doesn't have any context. Okay, each and every agent has its own memory, but the chat memory that you normally have for agent is local to the single agent. Okay, so the medical expert knows that I broke my leg, but this is at this point, this is the very first time when I'm querying the legal expert. So the legal expert doesn't know anything about what happens before. Okay, so this is the problem. It's missing the context of the conversation, because yes, there is a context, but it is in a different agent. So the idea of the agentic scope, as I said, is not only to have to provide a shared state for the agent, but also to provide a shared context that eventually the expert can use. So let me go back to my application, to the legal expert, and here I can say, okay, the legal expert also is provided with a context that is the summarization of the interaction that the agentic scope had with the two other agents. Okay, so I don't need to restart the server because again this is Quarkus running in dev mode, so I have the auth reload. I can go back to my web app and let's try to do again the same interaction as before. So I can say again, okay, now you know what's going on. I told the system that I broke my leg. This is going through the medical expert, which is replying to me, and then I can ask again if I should sue my neighbor who in a way or another made my leg to be broken. And let's wait for the so now the answer goes to the legal expert, but now you can see that the answer of the legal expert is different in a very relevant way. The legal expert knows about my leg injury and is replying me knowing the context, knowing what happened before in the agentic system. Okay, so what the agentic scope is doing is injecting into the question to the legal expert not only the user question, but also a summarization of what happened before within the rest of the agentic system. Okay, please feel free to interrupt me and to ask question if you have any question. Okay, so back to the slides. Okay, so far, okay, there is a question about streaming. So at the moment, with LangChain4j 1.10, no, streaming is not supported. I have a pull request that is already merged on the LangChain4j main, so it will be available with LangChain 1.11 that will be out, I believe, in a couple of weeks. With LangChain4j 1.11, we support streaming agent. What happens here is that, of course, if one agent needs in input the output of the former agent, then if the former agent is streaming, the downstream agent, the agent that needs in input the output of the first, needs to wait the whole streaming to happen. Okay, but if the system knows that the streaming agent is the very last in the workflow, for instance, is the last agent in your sequence, then at that point the workflow can stream the response of the last agent. So this is how it works. Okay. And again, this thing will be available with the next release. Okay, thank you. Okay, so far we spoke about the workflow pattern, but the workflow pattern decide in a very rigid programmatic way the sequence of agent to be called. Okay, we also wanted to make this a little bit more dynamic and leverage the LLM not only for the single agent, but also to create a plan of agent invocation. Okay, so we have in Agentic LangChain4j this other pattern which is called the supervisor pattern. In this case, you don't have a workflow that is fixed in advance, but we have another agent that is called the supervisor that creates the plan for you. Okay, so this is how it works. The supervisor, it provider with a set of subagent, exactly in the same way as we did for the other pattern. So the sequence, when you give 3 subagent to the sequence, you know that those 3 agents will be called one after, rigidly one after the other. Now I'm giving the subagent A, B, and C to the supervisor. In this case, the supervisor knows the features of each of these 3 agents that I'm providing, and decide which is the next agent to be called based on the user response and the request and the current state. So in essence, at each iteration, the supervisor generates this object that is called the agent invocation, that simply contains the name of the agent to be invoked, together with the list of arguments to be passed to that agent. Okay, so this is a loop up until the supervisor decide, okay, I'm done, and then I can give the response. Okay, so this is the agent that you don't need to write it. I actually spent some times to craft this prompt, and I'm showing you only part of it, to be honest. But anyway, this is how these internal agent work. So the important thing to notice is that it has a definition of done. So when the supervisor decides that it is done, it generates a special instance of that agent invocation response that is named done, and at that point I know that the workflow is finished, and it also generates knows how to pass how to generate the calls for the different agent, and how to pass them the arguments. Okay. Okay, and this is the user message of the planner. The request of the user is passed as the user message to this planner agent, and you can also customize. You have an extension point to customize this user message eventually. So this is in reality the whole picture of what happens when you use this supervisor. So the planner agent either decided that it is done and then return a response, or it invokes an agent. When it's done, in reality, 2 things can happen. I mean, what happens is that you may be interested in 2 kind of responses. In some cases, you are interested only in the very last agent response of the very last agent that has been invoked. In some other cases, you want a summary of all the interaction made by agent. Okay, so for instance, in the writer and editors sequence example, if you use a supervisor for it, then you are not interested in the whole interaction, in all the interaction that the supervisor did to generate the story, but only in the final story. Okay. In some other cases, you want a summary. So what you have is that you have another LLM who decide which of the 2, which gives a score to these 2 possible responses, and return one of the 2. Okay, so let me give you another example. In this case, I have 3 agents, one that withdraw US dollars from a bank account, another that can credit US dollar from a bank account, and a third agent that provides the exchange rate between 2 currencies. Okay, so I'm creating this functional bank, which is the tool used both by withdraw and credit agent, and I have 2 bank account with $1,000 each in this bank, and also I have my exchange agent that uses an external tool, for instance, let's say a REST endpoint, to decide what's the current exchange rate between two currencies. And I'm providing these three agents to my supervisor. So I'm telling to this thing, transfer 100 euro from my account to the ones of my friend Kevin, and this is the reply. Okay, so as you can see in this case, you really want a summarization of all the action taken by the agent, and this is what this thing is provided to you. You don't want only the response of the very last legend, but you want the story of what happens. And the supervisor figured this out and is reply accordingly. What happens under the hood, as I said, is that the planner agent generate this sequence of this agent invocation. Okay, so the first thing that this does is that if it figures out that it needs to know how many dollars corresponds to 100 euro. Okay, and the exchange agent replies with 115, and then it credits Kevin's account with 115 and withdraw the same amount of money from my account, and then it returns a fourth agent invocation, which is this special agent invocation that is named Don, and decide and containing as the response the summarization of all the action taken. Okay, so this is how the supervisor work. Okay, and if you want to exercise all the pattern that I discussed so far, there is this nice web app made by Rory Preddy, a friend of Microsoft. He did mostly the front end part, and I helped him a bit with the back end. But if you go to this URL, you can put this thing at work, and maybe I have okay, I have it here. I just exercised the sequential workflow, so I'm prompting the workflow this way, and this is the response that it gives to me. But it's also so okay, you can visualize the workflow here, but it's also interesting that of course all the agentic system is fully observable. So there are events that are emitted when an agent is invoked and when the value, the result is returned. So you have here the list of all the events that happened during the execution of this workflow. Okay. So this was the third step of my story, and then there is a fourth one on which I started working. Let's say immediately after the Devoxx Belgium. Okay. Because at the Devoxx Belgium, I had lots of interaction with people who started using my stuff and giving a look, and they started telling me, okay, but I have this specific need. I would like to implement this pattern. Why you don't have this? So I figured out in essence that there is no asides that fit all the needs. I cannot know upfront which kind of execution flow you want, which kind of pattern you want to implement. Okay, so I reworked my stuff and make it this pluggable. So what you can do is now all the pattern that I discussed so far, the workflows, the different workflows and the supervisor are implemented in terms of this pluggable planner thing, and you can implement and plug your own implementation. So let me give you a concrete example. So in essence, what I introduced is this planner interface. that is basically the three methods that you need to implement. You have a method that is called when your planner is initialized, and then the first action to take and the next action. Actually, I split this first and next action into method because it's quite convenient. Often for the very first action, you need to do something different than for the next one. But in reality, as you can see, there is a default implementation. So the first action fall back to the next action if you don't need to do any special during the first invocation. Okay, and this action that you return is what the planner has to do, which is the next agent to be invoked. So let me give you a concrete example. As I said, all the patterns that I had have been re-implemented in terms of this planner interface. Okay, so now the sequential workflow is implemented this way. It implements the planner interface. This is my sequential pattern. And what it does here is that during the initialization, the only thing that I do is reading the list of sub-agents that have been registered on this sequential pattern, and I store them. And I don't need to do anything special for the first action. So just let the default implementation to call the next action. And the next action, what I do is I just increment this cursor. So if I reach the end of the list, I return this done action to say, okay, I'm done, the workflow is finishing. Otherwise, I tell to the planner, call the next agent in the list, and that's all. Okay, so this is how the sequential workflow has been re-implemented in terms of this planner abstraction. So what you can do is that this time I'm not saying I have a sequential I'm building a sequential thing or a loop. I'm building an agentic system based on this planner, and to tell to this thing which planner implementation to use. I'm just passing there the supplier of the planner to this builder pattern. Okay, that's all. So in essence, using the LangChain4j API, you can either use the sequential pattern or call the sequential pattern by instantiating an instance of the sequential planner in this way. These things are totally equivalent now. And this allowed me to let's say, unleash my fantasy and create other kind of planner. Okay, so you can really create your own implementation of agentic pattern. Okay, so this thing that I did as an example of how to make this pluggable. I wanted to implement a goal-oriented planner. So what this thing is doing is, again, taking the list of agents, and then it created, with a well-known algorithm, it creates a graph of this agent using the input of the agent as precondition and the output of the agent as goal. And then it creates a list of agents to be called to reach the given goal, and it calls them after the other, like in a sequence. Okay, this is the thing. Sorry, I had some call out to explain what this thing does, but these are what I was describing. The final output is the goal, and then it creates this list, calculates this graph based on the goal and the list of precondition, and then once it's calculated, it invokes the subagents in a sequence one after the other. That's all. So to give you an example, I have these 5 independence agents. One that from a prompt extract a person, and another one that from the same prompt extract a zodiac sign, and an horoscope generator that from the person and the sign generates the horoscope, and finder of a story on internet for that given person, and horoscope that generate a funny story, and then I have writer that takes this argument and generates a write-up. Okay, so these are 5 totally independent agents, but I feed these 5 agents to my goal-oriented graph, and here again I need a goal, right? I need to know which is the latest outcome of this agentic system. Of course, the goal is the output of the whole agentic system using this goal-oriented planner. Okay, so at this point, I know that my final goal is the write-up. Okay, knowing this, I can create well, the algorithm can create the graph of the invocation to be made to reach that given goal. So at this point, I know the sequence of the agent to be called. The prompt is the initial precondition, so I know which are the first agent to be called, and I call all the agent in this sequence following the graph up until I reach the latest agent, the writer. Okay, and what is also powerful about this approach is that, of course, you can still mix different patterns. Okay, for instance, if you think about it, this goal-oriented pattern is probably nice, but it has a problem. It may have a problem. It doesn't allow loop structurally because it finds the shortest path to reach the goal, and the shortest path by definition cannot have a loop. Okay, but maybe you want a loop to review the final write-up and edit it until you are happy with it, right? So structurally, this thing doesn't have a loop, but what you can do is creating a loop with the workflow API of the agent, and have this loop as a sub-agent of the goal-oriented pattern, provide the loop as a sub-agent, and in this way you can have both things. You can have the goal-oriented pattern and also loop inside it. So you can really mix all the patterns that are provided out of the box by LangChain4j and your own pattern as you want. And okay, so what I did is that, okay, now at this point you can create your own planner definition. So what I did now is that I have one more module in my in the agentic part of LangChain4j. In this other module, I'm accumulating this new planner that I'm creating now. So at the moment, I have this goal-oriented pattern plus another pattern that I call peer-to-peer, where the agent doesn't have a common coordination point, but talk to each other. But the idea is that there is this module when I want to accumulate different planner implementations. And I'm hoping that users will start providing their own implementation, so I can grow this library of pattern for the agentic system. Okay, I'm almost there. So these are the 4 steps story that I want to tell you. This last part is just to say that, of course, you have many more features. You have a way to have a callback to decide what to do in case of an error. You can have non-AI agent. This could be useful in some cases. You can have agents that are not backed by an LLM. Okay, and you want to mix this in a pattern with other agents. So, for instance, if you remember, I had that exchange agent that calls a REST endpoint at the end to know the current exchange rate. But this is quite wasteful. Okay, maybe I can create an agent that that is not based on an LLM. It doesn't use an LLM, but what it does is that it just programmatically calls the REST endpoint to know the exchange rate. So you can create also non-AI based agent and mix them with all other agent. This is another interesting feature on which I'm still working a bit, but in essence, this is also quite useful. From time to time, you may want to have human interaction. So what you can have is this human in the loop, which is a specialization of a non-AI agent. And what it does is that it blocks waiting for an user. It gives a prompt to the user, waiting for the user response, and block for the human interaction before moving forward. So this is useful in case, I don't know, you want to ask a user to take an action. For instance, I don't know, an agent generate an email to be sent, and you want to review the email before sending it. So you can put this human in the loop in the middle. Okay, this is another interesting feature. What I have is you can decide that an agent is asynchronous, meaning that in this case, the agent invocation is performed on a different thread. So other agent can be invoked in the meanwhile. And if there is an agent downstream that needs the input generated by this asynchronous agent, only at that point there is the downstream agent is blocked, waiting for the response generated by this async one. Okay, and I use these features also to implement the integration with the streaming chat model that I was mentioning before. In that case, you have an async agent that is streaming, and if the streaming agent is in the middle of the agentic system and an downstream agent needs the full response, then it's treated as an async agent waiting for the stream to be completed before moving forward. Of course, I have A2A integration, so all the agents that I discussed so far are local, but you can have an agent that runs on an A2A server, and you can just configure it by giving to it the URL of the A2A server, because an URL uniquely identify an agent on a given URL. There can be only one agent that is running, and of course, still you can mix. A2A is a protocol made by Google. A2A means agent-to-agent communication. So it's a way to run an agent on a different server, on a remote server. So you have an agent that provides a service, I don't know, that provides weather forecast or whatever you want on a different server, and you invoke with this protocol this remote agent that is not an agent that runs locally. And of course, you can mix both local and remote agent in your agentic system. Okay, as I said, I always showed you in my slides the programmatic API, but as I said, you also have a declarative API. This is especially nice to use when you use the Quarkus extension, but you can use it also with vanilla LangChain4j. What Quarkus gives you is that it gives you CDI support. Okay, so if you use the declarative API with the Quarkus extension, you can also inject your agent, for instance, in your present point, for instance. Okay, and there is much more to this. As I said, I implemented support from streaming agent. Now I'm working on a multimodal agent, meaning an agent that can also take or generate image, for instance. And this is still lots of work in progress. So check the next releases for more feature. But this is really what I have for now. Is there any other question? Or if you have any other feedback, any other suggestion, any this is really an open process. So it happens very often that somebody asks why you don't. It happens for the streaming model. Why you don't are not supporting streaming model? Then I figured out I was missing them, and I implemented support for it. So this is to say, please let's stay in touch. Go on the GitHub project and provide your feedback and your feature request, and let's discuss this, because very likely I'm missing something that is very specific of your need, and the feature is not there not because it's not possible, but just because I didn't think to it. That's the reality. Okay, so I guess there isn't any other question for now. Okay, so thanks a lot, and again, let's stay in touch.